Good morning. So I am really excited to be here at the very first RabbitMQ Summit and the first speaker, a lot of pressure. And the journey for me with RabbitMQ started longer than I care to admit. I was an early adopter, fleeing from another message bus technology and trying to stay within the open source space. And in that, I was forced to learn a lot of things really early that have helped me develop application architectures that use RabbitMQ that hopefully most of you wouldn't have to think about these days. One of the very early things that came to me was that to truly grok RabbitMQ, just at the deepest level, is to know AMQP, specifically these days 091, back then 08. And that's kind of a weird concept, right? When you think about how you use other technologies, database servers, web servers, you generally don't think about the low-level protocol or the model implemented in the protocol. Hopefully, if you're a web developer, you're thinking about HTTP and using the constructs in it, but you're not thinking about it at, say, the layer 7 framing of how it works on the TCP stack. And to some degree, that knowledge with Rabbit is truly helpful. When you think about, as you go through the life cycle of being a developer who's using RabbitMQ, you start off with these questions of, how do I take a message and put it in a queue? Wait, what's an exchange again? Wait, I got to publish to an exchange, and then it gets into a queue. How does it get into the queue, right? A routing key, okay. So you start working through your mind this idea of the model of how a message flows through the system to get to where you have it in a queue, and then how do you get it out of the queue? Then you're writing your application, you're working through this process, and you start to run into issues. How many of you have applications in production where there are behaviors that you didn't expect in your application? That's it? A lot of times, the problems that you encounter in your application where the behaviors are not what you were expecting is because there are some things around the AMQP protocol at the lowest level that RabbitMQ implements that maybe aren't as straightforward as you would expect when you have experience working with other remote systems. And that's primarily because RabbitMQ's identity has evolved and is focused on this standard called AMQP. And AMQP itself is a standard that is a low-level protocol. That's like the framing on the wire, how data gets marshaled and unmarshaled. It's also the classes and methods around how that low-level data says what it's doing or what it wants. And then it's the model of the data as it exists in RabbitMQ. So if you bear with me here, we're gonna dive a little deep, and then we're gonna come back out. And if I'm going too deep for this early in the morning, I apologize, but I promise you, it's actually really early where I'm from, and I'm usually not awake for another 5 hours, so bear with me. So at the highest level, you have the model, right? This is the easiest part to understand, but these are the beginning questions. We have exchanges, and really when it comes down to it, exchanges are all about routing, right? And you have the message queue that accumulates things, and then you have the binding. One of the things that I always have fun when I'm working with a junior developer and I'm explaining this for the first time, and I tell them about routing keys, and then I tell them about binding keys, and they ask me, well, what's the difference between a routing key and a binding key? Well, they're the same thing, kind of. Depends on the exchange. And then we have the protocol. It's really the foundation of how everything in RabbitMQ talks. Everything. When things are happening inside RabbitMQ. You're using any of the functionality, for example, let's say shovels, or you're using any of the protocol adapters, which I'll get to, you're still talking AMQP 091. It just happens to be doing so internally as opposed to on the wire. Over on the right side here, we see basically the state that every connection has to go through when it's establishing a conversation with RabbitMQ. The connection starts, we basically send a salvo saying, hey, we want to talk to you in AMQP, and the server says, okay, let's start the connection. And it sends this response back, and then we have to say, okay, we got your response saying you want to start a connection. We're going to skip over secure because that's really not implemented most of the time. So we want to tune the connection. How many channels can we have? What's our maximum frame size? Few other things, and then as a response we say, okay, we got your tuning request, here's what we would rather do, and the server responds with, okay, your connection is open, and we say, okay, we understand it's open. Great. Pretty chatty. It's one of the reasons why short-lived connections to RabbitMQ are inefficient, because that's quite a few frames to go back and forth before you can ever do anything. And then the next step is you have to open a channel, right? So one of the things that you'll notice when we were going through that diagram is that we had this prefix called connection. And then we had on the right side open OK, tune OK. Connection in the AMQP protocol is a class, and the open and open OK are methods. And the protocol basically calls out for these different top-level classes, connections. And one of the interesting things, it's a bi-directional RPC protocol. And we have something that's kind of weird in the way that it was written for a normal developer. If you think about how you would have a channel and method, you're going to get a response back. But because the way the framing works, your responses actually come in the way of method calls as responses with arguments. So for example, the server sends a connection start, connection being class, start being the method, and we're going to respond with a method call of connection start OK, and we're going to pass arguments along with that. It's a little counterintuitive from that perspective. But what you'll basically see as you go through here, and I tried to highlight some of the important methods for these different classes, is that almost all of them have a basically verb OK response method to them. So with some exceptions, some important exceptions. But when you think through the life cycle of what happens at the low level when you're establishing a connection to RabbitMQ, you're going to basically establish that open connection, and then you're going to open a channel. And then once you've opened the channel, then you're going to do all the work. So you want to maybe declare an exchange, declare a queue, then you're going to want to bind the queue to an exchange. These have these nice call response, call type of behaviors until you get to the basic class. And I don't mean to be disparaging in any way, but I kind of feel like that was a little lazy catch-all class name, because it basically revolves around everything that doesn't have something to do with these top-level model objects. When you're publishing messages, consuming messages, getting messages, maybe it would have been better called message, I don't know. But anyway, one of the interesting things about basic calls is basic publish on its own, inherently, the thing that you use to send a message doesn't get a response. Finally, one really important thing that any programming RPC-style behavior has are exceptions, right? And so exceptions in the way of the AMQP protocol come as arguments that are passed by way of a channel close method call. And that's a really important thing to understand. When it comes down to it, channels, in essence, primarily are for the coordination of what messages are being sent across the bus when I'm at the message layer, and letting your client know when it's done something wrong. You tried to access a queue that doesn't exist. You published a message and you required that Rabbit route it somewhere and it failed to do so. And so that really is what channels are about. And it's important to understand what that is. Oftentimes, as a beginner mistake might be, well, I'm going to have this application that publishes messages from all these different parts, so I need to have a channel for each different part. That's actually costly when you understand what's going on underneath the covers in RabbitMQ, because those are different objects with statistics associated with them. It's keeping track of the message rate. It's keeping track of how many bytes are passing through. And it's useful, for example, if you want to coordinate behaviors because you want to know that this part of the application is causing exceptions within the RPC. But when you can, try and keep those things small. So this is where we dive deep. We'll go out of this pretty quick. But on the wire, at layer 7, does everybody understand what I'm talking about at layer 7? I'm talking about basically in TCP/IP, in the space that the TCP frame gives us to transmit data, we have binary data that is basically formatted like this. Pretty much every single frame that happens looks like this. And always there are exceptions, but in essence, we have a frame header with the frame type, this number that basically says, how am I going to format the payload? Then you're going to have the channel number and the number of bytes inside the payload and an end frame delimiter. This is somewhat opaque in that from a low-level perspective, what we're doing in all client libraries, in essence, is we're looking for this part, and we're looking for this part, and then we're taking that and passing it to a parser to try and figure out what's next. Next we have basically, what goes in that frame part I was talking about. I wanted to break down what happens when you publish a message. When you think about communicating, so for example, when we make an analog to HTTP and we're making a post call, at the top part of the post call on the wire, we're going to have headers that say we're going to post this and it's coming from here and here are how many bytes are there. And then we have this basically opaque payload. AMQP is a little different. We basically have a minimum of 3 frames. Remember a little earlier when I was talking about the connection state negotiation? One of the things that we negotiate is how big or how many bytes can each frame be? The default is basically 128K. And so what we send this frame that basically says we're doing a basic publish. And then we send information about what we're going to publish. That's where the message properties live. And information about the payload. And so if you're sending a 1 megabyte payload, you're going to send multiple of these body frames with opaque chunks. So the method frame, the very first frame, the basic publish, keeps our class, our method, and then the first argument is the exchange that we're going to publish to. Now this could be empty if you want to use the implicit direct publishing to a queue behavior, or it could be your exchange name, and then the routing key value, and then the mandatory flag. Every message that's published has that. And then every message that's published has this. And this is the content header frame. And you'll see there's a pattern here. We have these containers that then break down to another container that then break down to another container. In this case, we're saying we're a content header frame on channel number 1, and we have 45 bytes worth of data. And within that, we're keeping track of the body size. And then this awesome number here, there's a little algorithm with bit packing to determine what fields out of all of the message properties get carried along. So content type, app ID, the timestamp. And I couldn't see what the right field was, but mandatory, keep it in memory, delivery mode. And finally, we have the body frame. Notice this is a different frame type, 3, and on channel 1, and we have 55 bytes worth of data, and in this case we have a JSON payload. The JSON payload is opaque. The actual message body that goes into RabbitMQ is opaque, but it's the only thing about your message that's opaque to RabbitMQ, that it doesn't interrogate when your message comes in. When you're publishing to RabbitMQ, it actually is looking at, for example, the content headers and decodes the AMQP frame every time. How many of you have heard the advice or general philosophy that headers are slow? The AMQP message property headers. Only a few of you. That's cool. It actually can be true. As a generalization, it's not. But one of the reasons why it can be slow is basically for every message that you have this arbitrary key value table that is getting decoded every time a message comes into RabbitMQ. So if it's too big, it basically needs to allocate more memory. So not only does it have the opaque payload that, or the binary payload that comes in, but then it has to basically deserialize all that wire data into objects that it uses. The interesting thing is it's not the headers exchange that's slow, but merely the act of decoding the frame if you have too many values in the header fields themselves. So that's it. That was the low-level stuff. Did we go too low? No. So message publishing. So it's interesting. When you think about how do you answer questions about RabbitMQ, you may answer them at a high level, but really what you're doing is you're answering questions about the protocol or the model. So for example, in this graph, we talk about how do we publish messages as quickly as possible. At the fastest end, there's no guarantees in message publishing. And the reason why that's fast is it's fire and forget, right? We're just sending those 3+ frames for every message as quickly as we can. And if something happens to it in RabbitMQ, that's great. If nothing happens, I don't care. For me, in the ways that I use RabbitMQ, that doesn't work for our business. I would imagine that for most of you that's the case as well. So next, as we go down here, you can see as we get to safer and safer guarantees around message delivery, it gets slower. And so then you have to think about why is that? And so when we think about notification on failure, what does that mean? It means that we're telling Rabbit, hey, we want you to take this message and then tell us if you couldn't route it. If basically the routing key that we provided you in combination with the exchange left it in a state where you couldn't put it into a queue. And then we have publisher confirmations. Publisher confirmations are awesome. They're very lightweight compared to all the other alternatives, which is to say that when you send those 3+ frames to publish a message, RabbitMQ is going to acknowledge the fact that you received that message. And if you're a fast publisher, it'll acknowledge the fact that you sent that message or maybe multiple messages. But really, when it comes down to it, the notification on failure is going to come in the way of a channel close RPC. Publisher confirmations are going to come in the way of a basic ACK RPC. Alternate exchanges are not part of the AMQP protocol, but are an extension to them put in place by Rabbit. And basically what it's going to do is, in the case of failure to route a message to what you've said to route it to, it'll put it somewhere else. HA queues, or mirrored queues. They're slower, but they're only slower because that message is coming in and it has to replicate out across all the RabbitMQ nodes in the cluster that you've defined from a number of replicas that you want in the queue. Think of it like multi-master replication in a database. It's got to arbitrate, I've received this message, I know it's in all the queues that it's supposed to be in, I've published it out, I know it's been removed. So that's what makes it slower. Transactions. So that's the TX class within AMQP. That's pretty slow. Just like with databases, in fact, it is a database transaction with commit and rollback. I would advise you just steer clear of it. They implement it, it's in the spec. But there are other ways to get at that. So then when you start combining things like HAQs with transactions, obviously these are additive in the operations that they're performing at the protocol level or at the cluster level. So that's why they slow down. And finally, persisted messages. Now, I could have persisted messages with no guarantees, but they're still slower. And that's because it's writing it to disk. So if you think about what RabbitMQ is doing underneath the covers, it basically has a database. And if in that same analog, every queue is a table. And you're appending rows to those tables and removing rows from those tables when you're dequeuing. And so if you have delivery mode 2 where you're persisting messages, now we have to write it to disk, fsync, and wait for the file system to say, yes, I've written that message to disk, which obviously is slower, which means that you need to have hardware that can support the I/O that you want to put onto disk. Oftentimes it's easy to get into something like a message bus and not think of the ramifications of those things. Of course you want message guarantees. Of course you don't want to lose anything because you're using RabbitMQ as a central part of whatever application you're writing. It's mission critical or it's important to your business at the very least, and you don't want to lose anything. But finding the right balance of message guarantees is really important because overdoing it can lead you down the road to, why is this so slow? Likewise, we have the same types of questions about receiving messages. Generally, on the performance side, we have the same type of concept. What's the fastest way? How do I get my throughput to be really high for this application? Again, it comes down to the protocol and the things that we're asking of the protocol, right? So for example, at the fastest level, what you want to do is you want to consume messages. And the reason why you want to consume messages, as opposed to at the very other side of here of getting messages, is because of the protocol. Consuming messages takes your application and it says, hey, RabbitMQ, send me messages as quickly as you can after I ideally acknowledge that I've received them and processed them and told you can remove it from the queue. And so that from an operational perspective looks like RabbitMQ saying, hey, here's 3+ frames for this message. Your application processing them and sending a basic acknowledge, a basic ACK back to RabbitMQ or a basic reject or NACK back to RabbitMQ saying, hey, we're cool, send me the next message. As opposed to getting messages, which is a basic get method that is saying, hey, RabbitMQ, do you have any messages in your queue for me? And Rabbit's going to say, hey, okay, let me go look. It can't do any optimization around trying to figure out how to send those messages to you as quickly as possible. You're just asking, give me one message. And then it's going to send it to you in a response, and then you're going to process it, and then you still have to ACK it. So it's not a very efficient way to get those messages. So we look over here at QoS greater than 1. QoS prefetch is basically telling Rabbit how quickly can this one connection, this one channel process messages. And based upon that, Rabbit's going to try and optimize to pre-allocate out of the queue that many messages and send them down to you. And so sitting in your TCP buffer on your machine are going to be that many messages for your client to pick up and process if there are that many messages in the queue to give you. So it is the fastest way to go. But a common mistake is to say, okay, I want you to send me messages as fast as possible, so why don't you send me 100 at a time? Now the problem with doing that is, let's say that you're trying to parallelize. So you have 100 consumers on a queue that have all said, give me 100 messages ahead of time, and then they can only process one message a second. you get into a very inefficient condition where you've pre-allocated too much and actually your throughput goes down pretty dramatically. Whereas if you just said QoS 1, because you can process 1 message a second, it's going to send you those messages as quickly as you can process them and get them into the pipeline. And it's going to distribute them better so that you don't have aging messages sitting in the TCP buffer on your machine. Make sense? So NOAC mode. Technically, you might say this could be faster. But what happens in NOAC mode, and I probably should have qualified this in the graph, is with a single consumer, NOAC mode is going to be the fastest way to consume messages. And that is, RabbitMQ is just opening the fire hose and sending you messages as quickly as it can, as quickly as it comes into the queue. They're going to sit in your TCP buffer. The problem with that is, unless your applications have some sort of really, really awesome way of dealing with understanding what data is available to it before it ever gets to it, which probably is not something that's possible. If you were to segfault, your application were to be restarted without having some sort of graceful way to tell Rabbit, hey, I don't want to receive messages from you anymore, and then wait to ensure that all your messages have been processed, you're leaving messages in the TCP buffer and they're gone. So you've lost data. So on the other side, consuming with acknowledgements is going to be slower. So QoS, you're not worrying about it. You're just saying basic consume. You're receiving the messages. You're acknowledging them. And you're just getting them one at a time as they go through. Transactions are even slower. But again, getting is the slowest. All really low-level protocol stuff, which you don't really think of as an application, or you shouldn't have to think of as an application developer. But as a rule of thumb, when you're working on these applications in production from an operational perspective and figuring out what's going on, you start to just kind of understand the behaviors from this perspective, even if you don't know why. So moving on from the low-level part of the protocol, I want to ask the question, how will you use RabbitMQ? So I'm sure most of you are familiar with the term not invented here syndrome. Basically, when you think about how you use RabbitMQ and the AMQ model, and the way that you deliver messages, there are multiple paths that you can go down. There is the do-it-yourself method. And I think this is probably one of the more popular ways to use RabbitMQ. Frankly, this is the same type of thing that happens within the HTTP stack with web developers. We have a protocol that has explicit contracts that allow us to define behaviors. And we may bypass that and say, hey, I've got a message body. And so in the message body, I'm going to give my other application all the information it needs to be able to know what to do with the message body and the message content itself. The same type of thing happens in HTTP, where you don't embrace, for example, status codes in your responses beyond 200 or 404. And not realize that, for example, 429 is used for rate limiting. You may just have, I'm going to return a 400 error to you, and in my JSON response, I'm going to have an error that says you've been rate limited. The same thing I've seen in multiple RabbitMQ environments where we may have a JSON payload that provides context around the message and the message itself. So as the picture kind of says, you end up building a tow truck that's sitting on top of another tow truck when RabbitMQ provides all that for you. So when I'm working with developers and talking about how to use RabbitMQ, I'm oftentimes saying, hey, use the model. Go look at the message properties. Figure out how you can combine exchanges and routing keys and message properties to provide the context to your messages so that the message body itself is as terse or limited to the content you actually care about at the message level, and go from there. So it's really interesting. This was a debate that I had very early on at Meet Me with my VP of engineering. I wanted to embrace the model and use properties to describe the message, and he wanted the flexibility to move away from RabbitMQ if we wanted to or needed to something else. And so his perspective was we take and we put everything in the payload, and our applications then understand how the contract of the payload works to determine how we do messages, what the content is, when the message was created, what it's supposed to be used for. And my perspective was, let's use the message properties for that because it's more efficient. Binary serialization and deserialization in AMQP in all of your client libraries is more efficient than JSON decoding if you're using JSON as your message payload body, which I think is probably the most popular thing to do. Who has any unusual or non-JSON based bodies that are not things like images? Very back. What are you using? Very cool. I do the same thing. I use Avro datums for my payloads. Basically, JSON or other serialization formats inside, non-contract-based serialization formats inside the payload body mean that your consuming applications and your publishing applications have to obviously serialize, deserialize those as well. There may be more efficient ways to get at that. So there are multiple ways to use RabbitMQ, obviously. One of the ones that is very obvious is to use it for your application's own RPC. How many people use RPC within Rabbit? Explicit RPC? So when you think about making your explicit RPC, I've highlighted in green all of the message properties that you should be thinking about using. For example, app ID. Perhaps your consumer applications for your RPC care about where the message is coming from as part of their decision process, as part of the logic of what's processing the data. Content encoding and content type are pretty obvious. But I highly recommend, even if you have an implicit contract in your publishing, that embracing content encoding and content type is a very good way to future-proof your application. Content encoding basically saying, I have compressed content. It's gzip and compressed or bzip or whatever it might be. Content type being the MIME type of the data as it's serialized, or if it's text or whatever it is. Correlation ID. How many people are using correlation IDs? Really useful when you're trying to debug your systems. Expiration and the idea of an RPC, by the time that the remote consumer that's processing and doing the work receives it, it may be too late. So by setting an expiration, you can let that consumer know to throw it away. Message ID is really important when it comes to RPCs because you want to be able to coordinate the response back and know that you're receiving back the right message in a highly concurrent environment, so you can correlate those things. And reply to. So obviously really important. And if we come through here, we look at this diagram here. I'm not using the built-in, I forget, is it called fast reply to? There's a built-in reply to behavior where replies don't have to go through a queue. So obviously, I'm not talking about that, but we have this idea of a publisher and a consumer that is generating an RPC message, publishing to an exchange, it goes into a worker queue. Again, we have these combination consumer publishers that are processing and doing our work, sending it back to a response queue, and we're going to use the reply to header to say what that response to queue is going to be. Keeping track of the timestamp of when the message itself was published is important. I would caution against the use of timestamp to describe data within the payload. and instead, kind of contrary to what I've been saying about everything else, I would use this as an attribute of the message. Type, really important. Even if you're implicitly relying on behaviors in RabbitMQ of saying, hey, I know it's made it into this queue over here, so this is the type of RPC that I'm receiving. Having this data from either debugging or historical purposes or just validating from a consumer perspective in case of operational misconfiguration is really useful. You can interrogate this when you receive a message and say, hey, you know what? Somebody sent me an RPC to do something, and I'm not the type of consumer to do that, so I'm just going to discard this message, or I'm going to take some sort of alternate behavior. And finally, user ID, like app ID, really useful if you want to be able to interrogate those to determine if you are allowed to do the thing that you want to do. This is the way that I prefer to use RabbitMQ. How many people use it more like a fire hose of messages or events where you're just kind of publishing and you tack on all sorts of different consumer types to the same messages? A few of you? Okay, so again, we have these properties up here. You know, the same things apply to what I was saying. Coming over here in this concept, I may have different things coming in from my various publishers, in this case related to images. And by using the routing keys and binding keys, I can multi-purpose these messages. So having a new profile image could do all sorts of cool stuff, you know, give us our facial recognition, hash the image so that I could look for abusive patterns or that sort of thing, and store it in the case of something like Facebook. And then I might, all the way down here, just want to audit everything that's going on in my system. And so I could just say, give me everything related to images. I'm going to audit them. I'm going to stick them in logs or something like that. You know, it really allows you to multi-purpose that thing coming into RabbitMQ in an efficient way. So common user problems. And all these somewhat come down to not understanding AMQP, right? Who's had problems with heartbeats? I know it's more than 2 or 3 of you. Probably using the Python library or the PHP library, I would imagine. That's because heartbeats are bi-directional RPCs. Single-threaded applications that are doing work after they've received a message can't respond to the heartbeat request coming from the server. If you don't know the protocol and you don't understand that, what you'll end up with is a consumer application or a publisher application that is doing just fine. It's going, it's doing all its stuff, and then it disconnects and you don't know why. And maybe it disconnects at inopportune times, like you're in the middle of converting a very big video to a different format or something like that. Not understanding the throttling of messages. You know, you're publishing. You've got this application that basically is like a super high request rate application that's sending a message on every request to RabbitMQ, and you're not letting the client library breathe in a single threaded application, and you get disconnected or throttled. Somewhere along the line, RabbitMQ is trying to say, hey, slow down. You're using too much memory, or you're publishing too fast in relation to how fast you're consuming, and you're using too many resources. And there are multiple ways for RabbitMQ to respond to that. And the first way is, these days, is to send you a connection blocked RPC. So your application is going to receive a frame from RabbitMQ that says, hey, I want you to slow down, or actually, it says, hey, you're publishing too fast, and I'm blocking you from publishing. But if your application's not breathing, if it's not listening for what Rabbit's telling you, you're never going to know. So ultimately, the emergency brake in that scenario is TCP back pressure, where RabbitMQ just stops reading from the socket that you're sending data to it in. and that's not intuitive. And what ends up happening is your application ends up locking up or having some sort of poor performance related behaviors. And not understanding that bi-directional nature of the RPC protocol between the server and the client, and the fact that the server is going to send commands or invoke methods on your client. If you're not thinking about that, you can run into weird edge cases that you weren't expecting. Another fun one, which I mentioned before, is channels. So one of the interesting things of supporting client library in the open source world is the number of support requests you've received from people who are relatively new to using RabbitMQ and saying, hey, I'm trying to write this multi-threaded application or whatever it is, and I've got like 50 channels open doing all these different things, and I'm either getting poor performance or application behavior that is hard to figure out what's going on, and in essence, it's too complex. Simplify, bring it down. Use a channel, one channel per connection, period. And when that closes, open another one. If you want to have some level of concurrency in your application, maybe you need to open multiple connections. But beware, because connections and channels have overhead in RabbitMQ. This goes down to understanding how RabbitMQ is written and the fact that it's written in Erlang. And while highly efficient, every channel, every connection is a process within the RabbitMQ server in the Erlang VM. And so as you're opening them and closing them, you're basically using resources on the server side. And so if you have more than you actually need to do the work that you're doing, you're just making Rabbit work harder. And then you have slow performance due to poor choices. Well, one of the things that happened when I first came into Aweber was they had a RabbitMQ cluster, and they were using a Python stack, and they were using my client library that I had written, and they couldn't figure out why it's so slow. So they're like, Gavin, you know RabbitMQ. Hey, you know this client library. Your stuff sucks. It's so slow. And really, I'm like, well, that doesn't make sense because I have applications that are doing tens of thousands of messages per second, and they're not slow. And it turned out it was because they didn't understand the ramifications of delivery mode 2, like I was talking about earlier, where RabbitMQ was persisting every message to disk. They're thinking, hey, these messages are really important. And so we're going to have a 3-node Rabbit cluster running on virtual machines with 20 gig hard drives and 8 gigs of RAM and 4 processors. And we're going to publish 3,000 to 4,000 messages per second with highly available queues where it's synchronized across all 3 nodes. And we're going to write them to disk. Of course it's going to be slow. You're asking Rabbit to have multi-master replication with persisted rows. Not much you can do about that other than say, hey, where's the level of message deliverability guarantee that I care about, and go from there. So I talked about how knowing RabbitMQ or grokking RabbitMQ is to know AMQP, and it's really important in knowing AMQP that there are warts. I happen to both love and hate the protocol. I think it's really good in many ways. But if you go to the Rabbit site, you'll see there are 30 items in the 091 errata page. And that includes logic errors in the spec, incompatibilities between the versions in the low-level marshalling of frames, behavioral differences. One of the things that's really tough in, or at least used to be, was dealing with authentication failure issues. Because you would connect, and as spec'd, RabbitMQ or any other AMQP broker, if you fail to authenticate, it just closes the connection. And it doesn't even have an authentication failed exception response to that closing. It just closes the connection at whatever particular frame part of the sequence it was in that you're trying to establish it. So in the Pica library, I created an exception called probable authentication failure, which was to say that I think this is probably an authentication failure because of where in the startup sequence it occurred, but I don't know because it can't tell me. Fortunately, the RabbitMQ team added a capability and an exception code that will explicitly tell you that. But going back, a lot of what you heard me talk about was that bi-directional RPC nature. I think ultimately the fact that you can multiplex and do multiple things on a connection at any given time is somewhat of the root of most of the problems with AMQP 091. And so the responsibilities of a client really come in there. So with those warts, we look at what RabbitMQ has done to address those. And that's really cool. So AMQP is extensible, which is awesome. First is federation, and it's important to think about. You think about the features in RabbitMQ, and they're building on top of AMQP. So when you think about the behavior federation, it's implementing the AMQ model, and it just has built-in consumers and publishers that are working underneath the hood to do the things that you're doing. So with federated exchanges, we basically have an upstream queue. That's an internal queue declared by RabbitMQ that's bound to the exchange. And so your publishers are going into that upstream queue. And then you have the federated publisher that's consuming from that queue and publishing to the exchange on the other side. Now, it's important to say I boxed these off, but this guy can live here or here. And that's the case with all of these. If you have federated queues, right, it's the same. It's an AMQP model, or the AMQ model, I'm sorry. And we publish into the upstream queue. And if I have a consumer hanging off this queue over here, we basically have this consumer publisher that connects to the upstream and consumes messages and publishes them into that queue. In essence, you could write this stuff yourself. It's the same type of things that you're writing when you're writing publishers and consumers. It just happens to be built in. Same is true with shovel. These diagrams are not terribly different, but the behaviors of how they work are slightly different. If you're going to shovel to an exchange, you basically have your source queue and a consumer publisher built into RabbitMQ that's publishing to the exchange on the downstream side, or the destination side. If you're doing a queue, you basically have your source queue, and you have that consumer publisher that's going to that queue on the other side. Built into Rabbit. Maybe mysterious because you're just seeing it in the UI or you're seeing it from the command line. But ultimately, it's just like your applications. They're just written in Erlang as part of RabbitMQ, but doing the same exact things. Basic publish, basic ACK. Protocol plugins. This might be surprising to some of you. How many of you use protocols other than AMQP with Rabbit? MQTT, AMQP 1.0. Underneath the covers, the plugins are just translators that are taking whatever protocol you're talking, whether you're publishing methods or publishing messages or consuming messages, and they're turning it into AMQP 091 with an internal client and talking to it. Surprise anybody? No? And then there's all these awesome connections. I don't have a lot of time left, so I'm going to skip over reading through the list. But basically, the RabbitMQ team extended the AMQ protocol, adding new classes and methods. So for example, consumer or publisher confirmations, the confirm class is an extension to the AMQ protocol. Basic NAC is a correction of the fact that you can't multi-reject the same way you can multi-ACK. So they added a basic NAC frame that, or basic NAC method, I'm sorry, that allowed you to negatively acknowledge multiple messages. As I mentioned before, authentication failure notifications, all of the things, all the RabbitMQ specific stuff, these are extensions to the protocol itself or the spec or the methods. They're features within Rabbit, but they build upon the AMQP. Finally, I want to talk about the architectural impact of embracing AMQP. When you move beyond this idea of Rabbit as a message broker, and I'm going to shove all my stuff in the message and let my applications sort it out, you get to having simplicity, extensibility of your messages, using them for multiple purposes. You get some robustness in your application framework and flexibility in use. So using message properties, basically if you declare, instead of implicitly relying on application behaviors, that you're compressing them or whatever it is you're doing from an encoding perspective, you're specifying the content type, you're allowing consumers of those messages, no matter what the consumer is, something written in Go, Erlang, Python, Perl, PHP, Ruby, whatever it is, it should be able to know by looking at the content type explicitly how to deal with the way that the content is serialized or stored within the message body. Type tells those consumers information about the message that it doesn't have to divine from the message body itself. You get traceability and ease in debugging by using correlation ID and message ID. This idea of logging and being able to look across logs of all of your distributed applications and being able to correlate behaviors or a process by those IDs. And finally, better debugging. If you don't use App ID today, I implore you to go back to your applications and do it, because 2 to 3 years from now, when you're trying to do some sort of upgrade to a process and you don't know where the message is coming from, you're going to kick yourself. App ID is extremely useful from that perspective. Finally, by embracing this, you get flexibility in your messages. You can use them for multiple purposes. If you're not thinking about your messages beyond the scope of whatever it is that you're doing today, you're selling Rabbit short. So one of the things we do at Aweber is we think of these as events. What happened in our ecosystem of our application? And not only do those events get used by consumer applications to do the tasks that we need to do, they also get streamed into a data warehouse. So now we have this entire warehouse of an ecosystem of everything that's happened in our environment that now we can use for BI or whatever other types of analytical purposes we want to do, or recover from failures because behaviors happened in our environment that we weren't expecting. Any questions I can answer for you?
In the latest slide, you showed a plugin for the server 1.0. I just wondered whether 1.0 actually solves any of those problems and why Rabbit doesn't support one.
Well, it supports it by way of a plugin. It's a different protocol. It's rather unfortunate that they called it AMQP. I wish they would have named it something else, because inherently, if you look at the lineage of the AMQP protocol, it's quite different in its definition. And it does solve probably the biggest problem in that it's not as lenient in that whole multiplexing, putting multiple behaviors at any given time onto a connection. But it also doesn't implement the model in the same way. In essence, right now, the identity of RabbitMQ is this protocol. I think, and I obviously can't speak for the Rabbit team, but the things that I've seen them do as far as embracing and extending, that may not always be the case. But that's where we are today. Oh, I'm sorry.
Sorry, so quick question. You mentioned on the last slide about events. When do you see RabbitMQ the right technology for events versus something like Kafka?
For me, the flexibility that I gain from Rabbit that I don't have in Kafka makes it the right thing. That multi-purposing and explicit contracts. Now, admittedly, I have limited Kafka use, but the fact that I've got this very flexible model in Rabbit and Kafka itself is a little more rigid in that sense. It seems better to me. So for example, the way that we do our warehousing is we route all of our events to a single queue or a single set of sharded queues. And then we have one consumer application with a number of connections that listen off of that thing. And then we have different other applications that are connected to other routed applications. Yes.
How do you manage your Avro schemas?
So we have basically a Git repo and a web server Docker image that gets published and has those schemas, and then our applications, we use content type to specify that's Avro, and we use the type field to specify the schema name and version number that we're going to retrieve. And so publishers basically pull that in on startup, and consumers dynamically, when they receive a message, will go look to make sure that it's a supported type, pull it down, and use that from a deserialization perspective.
Cool. Very cool.
Well, very good. I appreciate your guys' time. This is my book. I hate to be the shill, but I think my publisher would be really mad if I didn't mention it. I go into all the things I talked about at a lot deeper level, but I think it's a pretty quick read, so I recommend that you pick it up. And thank you.